Okay, so we're going to move into the ratio and root tests. These are our last two tests. Let's go. Okay, so here is our ratio test. I don't think we're going to do any problems in this one. We're just going to talk about a couple of like factorials and things like that. So we have a ratio test. So we're looking at a sum of a sub k. It's an infinite series. And then we're going to create some ratio. There's going to be the limit as k goes to infinity, but we're pretty, when it says take the limit, it means take the limit as k goes to infinity. And what we're going to do is we're going to take our a sub k and we're going to put it in the denominator. And then up top, what we're going to do is we're going to add 1 to our index and we're going to see what happens. This is just saying, like, this is the term you're on. This is the next term. It's the next one. So we're trying to see, is it going to get bigger? Is the next term divided by the previous term larger than 1? Because if so, well, that's bad. That means it's getting bigger. At least absolutely it's getting bigger. So that's kind of the game. That's what we're going to do. So we've got to get accustomed to that. So if we find out that this r is less than 1, then we're going to say the series converges absolutely. Therefore, it converges. Well, if you say converges absolutely, you don't need to say it converges. It's in the word. If r is greater than 1, including infinity, the series diverges. And if it equals 1, you didn't find out anything. You found out nothing, which means you need to use a different test. And it's going to be our job to figure out which tests to use. So, all right, we're going to jump into this in our next video, start doing this. But before we do, what's going to pop up a lot, what you're going to see a ton of, are factorials. What is k factorial? I know we've done this before, but this is 1 times 2 times 3 times 4 times ... Let's call it k minus 2, k minus 1, and then k. There we go. Well, I'm curious. What's 10 factorial divided by 9 factorial? It'll be like 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. And 9 factorial will be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9, and then, those cancel, 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 and it equals 10. Cool. Cool. Well, do you mind, can we do this? K plus 2 factorial over k factorial. Can we see what that's going to turn out to be? Right, because I know a lot of us haven't dealt with too many factorials. I mean, you kind of see and you're like, oh, I can do that. It's no big deal. But can you mess with them? So this is going to be 1 times 2 times 3 times ... And then we're going to have some sort of k minus 1, some k plus 1, and then k plus 2. We're just going up to k plus 2. And now we'll do k factorial, which will be 1 times 2 times 3 times ... k minus 1 up to k. So as we can see, the 1's cancel, the 2's, the 3's, the everything else, all the way up to the k minus 1, the k, and the only thing that we're left with is k plus 1 times k plus 2. Ooh, good stuff, huh? These are our factorials. We gotta be solid with them. We gotta be dope. Gotta be amazing with it. And what's this? What's k factorial over k plus 1 factorial? Well, from the last one, I'm hoping you could see what it's going to turn out to be up top. 1 times 2 times 3 times ... Let's call it k minus 1 up to k. And then 1 times 2 times 3 times ... k minus 1, k plus 1. So everything else will cancel out. Cancels and just leaves you with 1 over k plus 1. Yeah. Gotta have it. Must know it. Gotta be dope with it. Okay. So we're going to mess around with these factorials inside of problems. Now, when you see a factorial, How do you integrate stuff like that? Could you integrate this? Oops, call it x factorial and dx. No, I don't have any ways to do that either. But what would work great is sums, not integrals. Sums would work great for this because we're moving into something called power series or a Taylor polynomial. Why we do all this stuff is so we can get built up to see it. So, yeah, we're going to deal with a lot of factorials. We're going to deal with a lot of the stuff from the past, plus that. And how's your algebra, dude? So, all right, I'm going to stop right here, make it just a short one just to begin with so we can see our factorials. Talk about that we have a ratio test, and then we're going to go in and we're going to do some problems next. So, all right, I'm going to stop this video here, and I will see you in a moment.